Hello, this is Mr. Burgess. Today we're going to talk about another transformation, but before we get into it, let's talk about a bell work problem. It's kind of a review question from way back in chapter 1 and 2. So we got a multiple step equation here, so right away we're going to grab a marker and get to work on it. First of all, we're going to use the distributive property to multiply 4 times x and 4 times 3. So when you do that, 4 times x just gives us 4x because we don't know what x is yet. And then 4 times 3 is 12, so we'll have a minus or subtract 12 right there. 7x plus 9 is what we have on the other side. All right, now we do the Great Wall of China maneuver. We're going to move all the x's to one side and all the numbers to the other. I think I'll move 4x over to this side and 9 over to this side. So when we do that, we're going to end up with 7x subtract 4x on the right side and negative 12 subtract 9 on the left side. And negative 12 minus 9 is negative 21. And all of that equals 3x. So we have to finish it off by dividing both sides by 3. So we divide by 3 like that. And we end up with x equals negative 7. So anytime you see a multiple step problem where you got variables on both sides, that's no big deal. You can do it. All right, so today we're talking about reflections. Yesterday we talked about transformations where we just slide an object around up and or side to side. This one we're going to be talking about flipping or reflecting an object over a line of reflection. So basically that's what a reflection is, just a flip or a transformation in which the figure is reflected in a line called the line of reflection. A reflection creates a mirror image of the original figure, as you can kind of see demonstrated. This first one, they're basically flipping the bike over a horizontal line, and in our assignment today, we'll be flipping it over the x-axis. In this case, they're flipping the bike over a vertical axis, which we call the y-axis, and you get an image that looks like that. So the original image and the new image will have the same size and shape. They'll just be pointing in a different direction. All right, so here's another look at its reflection across the y-axis. Here's a picture that's a reflection of this particular bridge in the water that the bridge goes over. So it's a pretty clear reflection, isn't it? There's a nice little review video on reflections if you want to check that out. I would recommend you do that. Okay, so the coordinate rules for reflection. So what we're going to learn about is some rules. When you flip from one side to the other, something happens to the coordinates, and we're going to mention that. So if we take a look at it, on this first one, we've got a equals 4, 3. So 4, 3 is the coordinates of a right there. Now, our next point after we've reflected it is called a with a little markup here that we call prime, is the word that they use for that. So what are our new coordinates? They are negative 4 and 3. So negative 4 and 3. So what we learned from this little maneuver is that when we reflect a point over the y-axis, if we have some point x and y, when we reflect it over the y-axis, then what we end up with is negative x, comma, y. The y value stays the same. The x value becomes its opposite. That's really important. That's going to help you a lot in some of these future problems. Okay, what if we reflect over the x-axis like this one? So let's take a look at point A again. Our point A happens to be at negative 2, 1, 2, 3, 4. So negative 2, 4. And then when we go to A prime, our second image, the reflected image, we find out that we're at -2, -4, -2, -4. So how does this change? What's different on this one? So in this one, when you reflect over the x-axis, the x value stays the same. So on the second image, the x value is the same, but the y value becomes a negative or opposite y value. So that's what happens when you reflect it across the x-axis. All right, let's just see how that works then. So we've got a point here, and we are going to reflect it across the y-axis. So again, what is the y-axis? Well, the y-axis happens to be this axis that goes up and down, right? So this line kind of lines up on the y-axis for us. So if this point is over here, to reflect it across that axis, we have to basically take the point and recreate it same on the other side, the same distance it is on this side. So it's over at -8, so we're on the same line, 1, 2, 3, 4, 5, 6, 7, 8, and that's where our new point is. So there's the reflected point, or A prime. Good. Okay, keep it going. Given the coordinates of a point obtained from each reflection, reflect the point -9, 4 across the y-axis. So -9, 1, 2, 3, 4, 5, 6, 7, 8, 9, 1, 2, 3. Here's -9 and 4. And we're going to reflect it across the y-axis right here. So we're going to go over to +9. 1, 2, 3, 4, 5, 6, 7, 8, 9, and up 1, 2, 3, 4. So there's our new point, 9, 4. So that in our little box here, we got 9, and we put 4, and that's what it would look like on Alex. Well, what about -9 and 4 across the x-axis? Well, if this is -9 and 4 right here, we're going to reflect it across the x-axis, which runs this way. That means that the x value is going to stay the same, and the y value will become its opposite. So we'll have a point 1, 2, 3, 4 down in this direction. So we'll end up with -9, -4. And that will be our new point. -9, -4. Okay, keep on moving. The figure below has a point marked with a large dot. First, reflect the figure across the x-axis, then give the coordinates of the marked point in the original figure and the final figure. Okay, so that's going to be a little trickier. So we notice we got this dot right here. So if we reflect this whole object across the x-axis, this is the x-axis, right? So this dot right here is 3 above, so we're going to go 1, 2, 3 below. This dot is 3 above, so we'll go down to 3 below for that corner. This corner is up 7, so we're going to go down to -7. And this corner right here is up at 7, and we're going to take it down to -7. But we're lining it up and orient it the same as we did on the other one. So now we've got our little line segments. So we have our new figure. And hopefully they're nice and straight. We could straighten this one out, I think. There's our new figure. Now, what is it asking us to do? Well, it wants us to give the coordinates of the marked point in the original and the final figure. So in the original figure, we have the numbers -6, 3, -6, 3, and that point here is -6, -3. All right, keep on moving. Okay, so there's going to be a few questions like this on Alex as well. Reflect the figure across the x-axis, Then decide if the statement about the reflected figure is true or false. So if I reflect, I'm going to just get these 4 points, reflect them across the x-axis. So this is down 3, so it's going to go up 3. This one is down 8, so it's going to go up to positive 8. This one's at negative 3, so it'll go up to positive 3. And this one's at negative 8, and it'll go up to positive 8. So there are our new corners of our new shapes. And as you can see, they look like the same shape, just reflected across the x-axis. Now the final lengths are shorter than the original size lengths. That's false. So we're answering a few questions about what we just did, okay? So let's get this. So that's false, right? Okay, the final angle measures are smaller than the original angle measures. No, they're exactly the same. The original figure and the final figure are congruent. That is true. That means they are the same size, same shape. If two sides are parallel in the original figure, then those sides may not be parallel in the final figure. So if you look, you got the top and the bottom that are parallel. When they reflect it, they're still parallel. So that's false. They must be parallel in the final figure. Okay, so in each part, reflect the solid figure exactly onto the dashed figure. If it is not possible, click not possible. Okay, so in a problem like this, which you'll see on Alex, you're going to drag this up and try and place it over the top of this. But so if you look at it, you'll notice that it's not even the same shape, so it's not possible. This one, on the other hand, is a reflection across the y-axis that you can see here, and so it would overlay nicely onto that one right there, and so that would be the answer to that one. And you will be able to do that on your Alex with the applications that it has available to you. Okay, reflect 4 and negative 4 over the x-axis. So 1, 2, 3, 4, 1, 2, 3, 4. There's 4 and negative 4. If we reflect it across the x-axis, which is this axis right here, then we'd go 4 and 1, 2, 3, 4. Okay, so there's 4 and negative 4. Then translate that. So we've reflected it across the x-axis, and then we're going to translate it 3 units to the right. So 1, 2, 3. So here's our final point. And then what are the coordinates of that point? Well, it's 1, 2, 3, 4, 5, 6, 7. 7, 1, 2, 3, 4. So our final point right there is 7, 4. Okay, I think that's we're getting close here. Let's see where we're at now. Yeah, so good luck doing the assignment, and let us know if you have any questions, and thank you very much.